eCOG1X 16-bit microcontrollers, Cyan technology. Welcome to this training module on Cyan Technology's eCOG1X 16-bit microcontrollers. This training module introduces the eCOG1X 16-bit microcontroller and its key features. eCOG1X is a member of the Cyan Technology eCOG1 family of low-cost, low-power microcontrollers targeting embedded communications applications. The eCOG1X product family is a range of low-power, feature-rich microcontrollers based on a 16-bit Harvard architecture with a 24-bit linear code address space, that's 32 megabytes, and a 16-bit linear data address space, that's 128 kilobytes. The devices are highly configurable with options including combinations of USB 2.0 on-the-go interface, 10 and 100 megabit per second Ethernet MAC, and 12-bit analog I/O. Each variant is available with 512 kilobytes of flash and 24 kilobytes of SRAM. Here is the block diagram of the eCOG1X microcontroller. The eCOG1X flash-based microcontroller contains a 16-bit RISC processor with powerful mathematical instructions. There are 512 kilobytes, which is 256K by 16-bit data words, of embedded flash memory, and 24 kilobytes, which is 12K by 16 bits, of internal flash of RAM available on chip, which can be used for both code and data storage. The internal memory manager maps both internal and external physical memories into the code and data space address maps of the CPU. The eCOG1X has a rich set of serial peripherals including UARTs, I2C, SPI, Smart Card, and Infra-Red protocol engines. A full set of hardware timer functions is available in the eCOG1X, providing 8 independent timers capable of performing functions such as clock generation, PWM generation, and infrared signal modulation. The external host interface, or EHI, enables fast data transfer between eCOG1X and an external microprocessing device. The eCOG1X includes an Ethernet MAC peripheral, which can be used with a suitable external PHY device. USB 2.0 compatible peripheral supporting low speed, high speed, and on-the-go modes. The eCOG1X has an advanced high-speed, low-power CPU with a powerful instruction set targeted at high-level languages, in particular C. The CPU is capable of operating at speeds up to 70 MHz. The CPU has a Harvard architecture, which means that it has separate buses for code and data spaces. The eCOG1 instruction set includes 42 instructions with 6 addressing modes. Most instructions operate on 16-bit word data values. The memory management unit allows the combination of a variety of internal and external memories into a single logical memory structure. The memory structure, or memory model, has both code space and data space address locations because the Harvard architecture CPU has a separate code and data bus. The memory management unit provides code space translations for program code and data space translations for variables and constants. The translation of logical memory addresses to physical memory addresses is required as almost all physical memories start with an address of 0. To avoid any address conflicts due to common memory base addresses and to create a linear address range, a logical memory address to physical memory address translation is provided by the memory management unit. The next few phases give an introduction of the eCOG1X device peripherals. The eCOG1X includes two identical dual UART modules, dual UART 1 and dual UART 2. Each dual UART module provides two separate UART channels labeled A and B. The two UART channels in each dual UART are independent. Each has a 16-bit divider that produces the 16 times oversampling clock enable for the receiver and the half-bit time clock enable for the transmitter. The lowest possible UART input clock frequency that allows for the correct divide-down baud rate should be used to minimize power consumption. The dual universal synchronous asynchronous receiver transmitter, or dual DUSART, is a general-purpose dual serial port, each of which can support one of the many fixed protocols. It also provides hooks so that the simple serial protocols can be defined by software. The hardware design has generic serial functions shared between a number of different protocol controllers. The generic USART serial port is duplicated for each channel and shared between each protocol control engine using an array of multiplexers. This allows any of the protocols to be selected for either channel, allowing for maximum flexibility. Note that each serial protocol may only be used once. The same protocol cannot be used simultaneously on both channels. The Serial Peripheral Interface, or SPI, is one of the protocols supported by the dual USART module. This gives the eCOG1X both SPI master and slave capability, with the option of supporting multiple slaves in master mode. Only a master can initiate a transmission, and the master provides the clock for the transfer. A slave must use this clock provided by the master for the transfer. Some support logic is included in the SPI top-level design to distinguish the data directions of both controllers and to supply flow control mechanisms for linking the data ports with the controller's framing functions. The Inter-IC Communication Standard, or I2C, is a bidirectional, multi-drop, multi-master, two-wire interface for connecting microcontrollers to their peripheral devices such as memories and interface ICs. It is capable of serial data transfer up to speeds of 100 kilobits per second, which is standard, or 400 kilobits per second, which is called fast mode, and 3.4 megabits per second, which is called high-speed mode. The dual USART is responsible for controlling the I2C serial bus by handling all of the low-level signaling and serialization of the data stream. This includes functions such as start and stop bit detection, address matching and arbitration, and clock synchronization. The diagram illustrates the functionality of I2C as implemented in the dual USART. It shows how I2C can be configured for either USART channel, and how the start channels and the I2C controller require register and peripheral interfaces to exchange control and data with the register bank. The IFR function in the dual USART provides a configurable codec designed for the transmission and reception of infrared data frames. Input signals should be demodulated externally before being supplied to the device for decoding. The IFR transmit data output signal may be provided both modulated and unmodulated. For a modulated output signal, the IFR transmit data output controls the PWM2 timer, and the output from this timer is the modulated data output. For an unmodulated output signal, the normal IFR transmit data output is used. The module is designed to be flexible, supporting current consumer products RC5, ASK, PPM, and potentially future infrared protocols via a programmable register interface. An outline structure of the IFR controller module is shown in the figure. The Smart Card Interface module contains all of the logic functionality required of the terminal or controller part of the Smart Card interface. Activation and deactivation sequences are supported with various degrees of automation. Protocol type T=0 is supported. Refer to the Smart Card standard ISO 7816 parts 1 through 10. It should be noted that while all of the necessary sequencing for card insertion, activation, and deactivation is in place, there is no built-in support for voltage level switching, tamper detection, or short circuit protection. It is therefore necessary that an external interface circuit is included between the chip and the Smart Card terminal itself. The User Serial Port module is an extension to the dual USART that allows direct software access to the features of the USART A or USART B. This port may be used as an additional UART. It is therefore possible to configure and use up to 6 separate UARTs in the eCOG1X, consisting of 4 UARTs from the 2 dedicated dual UART sections, and the UART and the user serial port from the dual USART section. The purpose of the USR function is to provide a flexible serial I/O port with multiple word parallel access and automatic parity insertion and checking, while minimizing the required amount of software bandwidth. User-defined serial protocols may be adopted by simply reconfiguring the USR register bank. The I2S interface, or Inter-IC Sound Standard, was developed by Philips Semiconductor to provide a simple, low pin count serial link for digital audio data. I2S is a synchronous serial protocol for sending and receiving digital audio data in stereo PCM format. The eCOG1X I2S peripheral provides both master and slave capability, programmable data size and clock frequencies, and simultaneous bidirectional data transfers. The LCD controller provides the eCOG1X with hardware support for driving simple static or multiplexed LCDs. The diagram shows an example connection to the microcontroller for this LCD driving scheme. The common backplane outputs must have tri-state capability, and the external resistors provide the third voltage level at half the power supply voltage. The segment driver outputs are standard logic outputs. The eCOG1X LCD controller peripheral uses this driving scheme with 1 to 4 common backplane outputs and 32 segment outputs. It supports 1, 2, 3, or 4-way multiplexing to provide control up to 128 display segments. The port multiplexer assigns peripheral functions to external device pins and can enable subsets of the LCD controller outputs for applications using smaller displays. The LCD controller automatically generates the required output waveforms on the backplane and segment outputs from the data values written into the segment data registers. The dual Smart Card Interface module provides 2 complete Smart Card Interface peripherals, independent of the single DSCI function available within the dual USART peripheral. The 2 DSCI cores in the dual DSCI are identical and are independent except for the shared clock and interrupt signals. The data input and output signals can be linked by the port configurator into a single bidirectional open drain signal or left as two separate signals, as appropriate for the hardware interface to any particular smart card. The eCOG1X includes an Ethernet MAC peripheral which can be used with a suitable external PHY device. Both the transmit and receive data paths have their own separate 128-byte FIFO to provide data flow buffering. Data packets are stored in the internal SRAM accessed via the DMA controller. The eMAC peripheral is controlled through a set of control and status registers located at an address defined by the memory management unit. The eCOG1X includes a USB 2.0 compatible peripheral module. It operates in USB host and peripheral modes with support for on-the-go functions. It supports low speed, or 1.5 megabits per second, full speed, which is 12 megabits per second, and high speed, which is 480 megabits per second modes. The USB core requires 4 kilobytes of working memory used for the in-point data buffers. This is taken from the top of the internal memory and cannot be accessed directly by the processor. Reading and writing to this memory is always done through the USB core FIFO registers or with the DMA peripheral and the slave FIFO. The eCOG1X includes a flexible analog control interface peripheral providing analog inputs and outputs. Both channels of the ADC are identical, except for the 2 internal analog signals which are connected separately, one to each ADC channel multiplexer. Both ADC channels have their input signals connected via an 8-way analog multiplexer. The DAC is an asynchronous 2-channel 12-bit digital-to-analog converter. The DSCI module includes an internal band gap voltage reference nominally at 1.22 volts for use with the ADCs and the DACs. The analog block also includes a power-on reset module which senses the analog supply voltage. The internal voltage reference circuit also generates a voltage linearly proportional to temperature. This is the internal signal which is available to the ADC as a temperature sensor input.